So today we're going to talk about the theories related to acid and bases. Acids and bases. So as we know, now pH scale 7 at 25 degrees centigrade. We're gonna see later also. That is acid and pH is greater than 7, that is base. So that is according to the pH. But what if we see the molecule, how can we say that they are acid and base? So different scientists came and they give different theory. Like first of all, we're gonna study Arrhenius. Arrhenius acid and base theory. So Arrhenius was a scientist who proposed this theory. So according to Arrhenius, what are acid and what are bases? So acid are the substances, right? According to Arrhenius, acid any substance which give H plus ion in water. It releases H plus ion on dissolving on water are known as Arrhenious acids. So there are various type of Arrhenious acid. Like first of all, monobasic or monoprotic, which releases H plus on water. Example, like there are example HF, HCl, HBr. This releases 1 H plus while dissolving in the water. The second categorization is dibasic or diprotic. Remember, in case of acid, we use the term base, dibasic, diprotic. So it is like which releases 2 H plus. 1 mole of acid releases 2 mole of H plus. Like we've seen in case of H2S, H3PO3, H2CO3, etc. Now third is tribasic or triprotic, which 1 mole of which acid releases 3 moles of H plus in the solution, like H3PO4, right? So 1 mole of H3PO4 releases 3 mole of H plus. So this is the categorization of acid. Now what are the categorization of base? So what is Arrhenious base? Arrhenious base are the base, like if we try to give the definition. So any base or any substance, in generalized we will be writing it as any substance which gives OH minus in the water, OH negative in the water, is known as Arrhenious base. Arrhenious bases are the base which on dissolving in water releases OH negative ion. Now it has also 3 categorization. We have written monobasic. Now here we will be writing it as a monoacidic. Monoacidic, like 1 mole of OH minus, which releases 1 mole of OH minus, like NaOH, KOH, NH4OH. Like what are the diacidic, which releases 2 OH minus, ZnOH whole twice, FeOH whole twice, CaOH whole twice. Now again it's triacidic, which releases 3 OH negative, like aluminum hydroxide, AlOH whole thrice, FeOH whole thrice. So these are the categorization of Arhenious base. One is monoacidic, one is diacidic, one is triacidic. In case of base, we use the term acidic, and in case of acid, we use the term base. Now, moving further, we're going to get the second categorization, that is known as Bronsted Lowey theory. So, according to Bronsted and Lowey scientists, so H, the substances which donates H plus donor are called acid, and H plus acceptor are called the base. H plus donor are acid and H plus acceptor are base. Like ammonia when react with water, it form NH4 plus OH minus. So ammonia has received the H plus and water has donated the H plus. So ammonia, in which you have received, that is known as base. Water has given H plus, that is known as acid. So NH4 plus base has a conjugate acid, and acid has the conjugate base. Remember, whenever the acid releases H plus, the remaining part is known as its conjugate base. And then when base gets H plus, its conjugate part is known as acid. So, like one more take example, HCl plus H2O. So HCl will give H plus in form Cl minus plus H3O plus. This is known as HCl is known as acid, and water is known as base. So HCl on releasing acid, so it will form conjugate base, and base on releasing getting H plus is known as conjugated acid. So how do we define what are the conjugate acid and base pair? So let's take down the definition. Acid and base having difference of H plus, either gaining or losing in terms of reaction, ion is known as a conjugated acid and base pair. So like in case of acid, when we remove H plus, the remaining is known as conjugate base. Like ammonia, when ammonia, if we take it as an acid, then not ammonia is not an acid. Like if we take an example like water, if we take an acid and removing H plus OH minus will be its conjugate base. In case of base, when we added H plus, it is known as conjugate acid. So in case of ammonia, if we add H plus, it forms NH4 plus. Then it is known as conjugated acid. So weak acid has strong conjugate base. So whenever the acid is weak, its conjugate base is strong, and strong acid has weak conjugated base. Whenever the acid is strong, its conjugate base must be weak. So it is same for base, like weak base has strong conjugate acid, and a strong base has weak conjugate acid. Now, acid and base reaction. Whenever there is a reaction between acid and base, it will always proceed in strong to weak part. I'm again explaining you. We have seen the very first case. The very first case was Arrhenius acid-base theory. So Arrhenius told that H plus donor are acid and OH negative donor are base. Now Bronsted Lowey, the Bronsted Lowey theory says H plus donor are acid and H plus acceptor are base. So whenever an acid donate H plus, it forms a conjugate base because it has again tendency to gain H plus. So that's why it has been categorized into base. Now when it has been categorized into base, the acid the stronger, weaker will be the base. Or weaker the acid, stronger will be the base. Or stronger the base, weaker will be the conjugate acid. Weaker is the base, stronger will be the conjugate acid. Now, on the basis of this concept that what I have written just, acid and base reaction, it will always proceed from strong to weak. We can write it also. From strong to, what does it sentence mean? It's a very important sentence. It will clear most of your doubts that you get in the reaction, why these two acid base react and why these two acid base doesn't react. You will get that answer in by helping this, with the help of this theory. Like if I give you a illustration or question, predict the direction of the reaction. We have to predict whether the reaction is going in forward direction or the reaction is going in backward direction. Like Na2CO3 when react with H2SO4, it will form Na2SO4 plus H2CO3. So Na2CO3, like if you see that H2SO4, it is the strong acid. Now H2CO3, it is a weak acid. Both of sides must there must be an acid and base. Both of sides. So we have to identify the acid. Here it is a strong acid and it is a weak acid. And Na2SO4, it is the conjugate base of weak acid. Let's say it is conjugate base of weak acid and it's conjugate base of strong acid. So we know that the reaction will always go from forward strong part to weak part. Whenever we have on the both sides we have acid or both sides we have base. So whichever we predict, like here we are able to predict the acids. We know in among H2SO4 and H2CO3, H2SO4 is strong acid, right? Until unless we saw the organic theory. In organic we will see a lot of factors which affect the acidic strength. But in case of inorganic, we can see that there are 6 strong acid and remaining are weak acid, right? So H2SO4 is among one of them. So reaction will always go from strong to weak, right? So the reaction will proceed in forward direction. In next case we have sodium acetate, sodium formate, and acetic acid. It will go in and CH3COONA. So it is weak acid and it is strong acid. Now this is acetic acid, this is formic acid. Now you will ask me, how can we identify whether acetic acid is a weak acid and formic acid is a strong acid? So the reaction, then all again I am saying you that in organic chemistry I'll explain you why the acetic acid is a weak acid and formic acid is strong. If you know a little bit, acetic acid is a plus I effect. I'm again saying if you know already the organic, then you will be able to identify. Otherwise, leave it on organic. It will be a very basic question in case of organic chemistry, general organic chemistry. Acetic acid is a weak acid and formic acid is strong acid. So here we are able to identify the weak part and strong part, right? So the reaction can't go from weak acid to strong acid. So this will be not a feasible reaction. So this is not a feasible reaction, or we can't say it is backward. It will not react. sodium formate and acetic acid together will not form a reaction. Like Cl minus and H2O, it will give HCl and OH minus. Now HCl and H2O, we know it is a strong acid and it is a weak acid. So this reaction is not feasible. If we take some more example, I hope you all understood what is the benefit of this theory. Fourth, like if you have this pyridine, right? So the pyridine, this is acting as a base, and here it is acting as an acid. So it will give H plus, right? So it will give H plus and N positive and NH negative, NH4, right? Here it will be positive and here it will be negative. Wait a second. It has given H plus, so it will be, I'm writing with different pen, it will be negative, right? And it will be positive. So if this is an acid and here, what is the acid? This is the acid. So between this acid and this acid, we know whenever nitrogen has positive charge, it will act as a better acid. Because on leaving the H plus, it will become a neutral molecule, so which is more stable than a charged species. So it will be not feasible reaction. I will take one more example. The Na plus, whenever it react with H2O, it will form NaOH then H plus, right? So sodium plus, whenever react with water, it is a weak base and it will form a strong base. So here it is, water is a weak base and NaOH is a strong base. So again, weak to strong reaction can't be proceed. So this is also not a feasible reaction, right? So one more type of substance we are studying under this categorization, that is known as amphoteric substance. What are the amphoteric substance? So the substances which can accept or donate H plus are known as amphoteric substance, which can accept and also can donate, right? Like in case of we say water, H2O, it can also accept H plus, then it is known as H3O plus. Now H2O, it can again donate H plus plus OH minus. So it can also accept H plus, it can also donate H plus. So these are amphoteric. So what are the other examples of amphoteric? Like if you take a series H3PO4, this is an acid that releases H plus, it will form H2PO4 minus. So that also releases H plus, it will form HPO4 minus 2. That releases H plus, it will form PO4 minus 3. So when it is at H plus, here if we add H plus, here if we add H plus, right? So if you see H2PO4 and HPO4 minus 2, these both can accept or donate H plus. So these are known as amphoteric substance. These can also accept and donate H plus. These are known as amphoteric substance. Other example could be like H2CO3. It can give HCO3 minus, and it can give CO3 minus 2. If we add H plus, it will form this. If we add H plus, it will form this. So H2CO3 can accept H plus and donate H plus. So this is also known as amphoteric substance. right? So these are the known as amphoteric substance. So that was all about this theory. One more theory we can have, like Lewis acid and base pair theory. Lewis acid and base theory. So what are the Lewis acid and base? So Lewis acid is actually a lone pair acceptor. So the acid which accept the lone pair, which has vacant d orbital, like vacant orbital, no, it should not be particularly like vacant orbital. These are the known as Lewis acid. Example, AlCl3. AlCl3 has a vacant orbital. If you write the configuration, if you go into the chemical bonding, you can write all the electronic configuration, and according to VBT, you can fill the chlorine and chlorine bond, chlorine and aluminum bond. You will see it has only 6 electron in outermost shell. The boron also has like 6 electron in outermost shell. BH3 you can take, right? BH3, it forms a coordinate bond with ammonia also. Right, so these are generally categorized as the Lewis acid. What are the Lewis base? Lewis base are lone pair donor, which have lone pair. These are the known as Lewis base, like Cn minus, OH minus, SO4 minus 2, like NH3 also. So negative charge means it has also a lone pair, and ammonia also has lone pair. So these are the categorized as the Lewis acid and base. So they both react. We gonna study that detail in case of organic chemistry. Alright, what are the Lewis acid and base?